SS1. Our subject today is mathematics on the topic number base. Number base is also known as radix. Number base is the foundation of the numeration system. It helps us know how many unique digits are there and how numbers are counted. Numbers are counted in bases such as binary, quaternary, denary. The most common is denary. But we have other bases like base 2, which is binary, base 3, which is trinary, base 4, which is quaternary, base 5, quinary, base 6, sextimal, base 7, septimal, base 8, octal, base 9, nonary, and of course base 10, which is denary, which is the most common I mentioned earlier. I'm sure in your basic 7, 8, and 9, they have given you the foundation of number base, right? So today, I will be teaching you how to solve complex problems on this topic number base. Solve for x in the following base 2 equation, leaving your answer in base 2. This is a wide past question. The question is 10x minus 1 bracket open 1 plus x bracket close divided by 10 equals to 101. If you look carefully, you will notice that all these figures are in binary. And for me, I think the easiest way to solve this question is to convert them to the base we are more familiar with, which is base 10. That's our number 1, number 2, number 3. So I'll try converting all these figures to denary so that you can solve it. If you notice and look carefully, you will notice that 10 is multiplying x, which is the same thing as 10 times x. I broke it down so it will be easier for me to solve for 10, so I can convert it to denary. So we have 10 is equals to, I usually put 0, 1, I count down, so it will be easier for me to multiply and not make mistakes. So 1 times 2 raised to the power 1 plus 0 times 2 raised to the power 0. And according to the law of indices, in binary, anything raised to the power 0 is 1. So we have equals to 1 times 2 plus 2 raised to the power 1 is 2 already, plus 0 times 2 raised to the power 0 is 1. So it's saying that 0 times 1. Then it equals to 2 plus 0, which is the same thing as 2. So 10 is 2 in base 10. So remember, we've separated this x from the figure when I was trying to convert. So I'm going to bring it back. So 2 times x is equals to 2x. So in denary, 10x is 2x. Let's move over to the next figure, which is 1. We're going to apply the same formula we applied here, but this does not have any variable attached to it, so we're going to just solve it the way we solve others. I won't stress myself solving for this because normally 1 in binary is 1 in denary, so 1 in binary is still 1. Then we have x, we are solving for x of course. Then we have 10. I solved for 10 while trying to get this 10x. And the 10 is 2. Therefore I multiplied it with the x. So of course 10 will still be 2 when I solve for it next time. Then we'll be solving for 101. So 101 is 5 in denary. So I'm going to solve all these figures in this equation. So where we have 10x, I'll put 2x. Where we have 11, I'll put 3. When we have 1, I'll put 1. When we have x, we put x. When we have 1, 0, we put 2. And when we have 1, 0, 1, I'll put 5. So let's start. We have 2x, which is this, minus 3. Bracket open, 1 plus x divided by 2 equals to 5. So if you look, it looks a whole lot easier to solve. So the first step after converting is to find the LCM of the denominator of 2x. And if you know, there's a rule in math that anything, a whole number, for instance 2 or 3, if it has to be in fraction, will have an imaginary denominator of 1. So same for 2x. 2x will have an imaginary number of 1. So 2x all over 1 minus 3, bracket open, 1 plus x, bracket close, divided by 2 equals to 5. Obviously, the LCM of 2 and 1 is 2. So we have denominator 2. 2 divided by 1 is obviously 2 because anything divided by 1 is 2. Then, when you divide, what you get from the value you divide from the denominator, you multiply with the numerator. So we got 2. So 2 times 2x before x. So we're going to put 4x here. Minus 2 divided by 2 is 1. 1 times 3 is 3. Bracket open. 1 times 1 is 1. Plus 1 times x is x. Equals to 5. We're going to be opening the bracket now. But first, I will multiply all this inside the bracket by 3. We have 4x minus bracket open 3 plus 3x bracket close all over 2 equals to 5. Now, when a negative sign opens the bracket, it changes every sign inside to the opposite. And since the inside bracket sign is positive, we're going to change it to negative. We have 4x minus 3 minus 3x all over 2 equals to 5. We're going to be collecting like terms from the numerator side, so it will be easier to solve. So we have 4x. If you look, it's 4x minus 3 minus 3x. And 4x and minus 3x are like terms. So we have 4x minus 3x minus 3 divided by 2 equals to 5. That means we have x minus 3 divided by 2 equals to 5. Then we're going to cross multiply. And if you cross multiply, for instance, it goes like this. So we have x minus 3 times 1 is equals to 5 times 2, which is x minus 3 is equals to 10. That means x is equals to 10 plus 3. X is equals to 13. But remember earlier on in the question we have solve for x in the following base 2 equation, leaving your answer in base 2. That means we're not going to leave it in denary. You have to convert it back. So we're going to divide it by 2 since we're converting it to base 2. 13 divided by 2 is 6 remainder 1. 6 divided by 2 is 3 remainder 0. 3 divided by 2 is 1 remainder 1. 1 divided by 2 is 0 remainder 1. So we're going to be taking this upwards. So we're going to put an arrow. So we're going to be taking the figures down, from down 1 to up 1. We're going to have equals to 1, 1, 0, 1 base 2. And this is your answer. So x equals to 13 in base 10 is x equals to 1, 1, 0, 1 base 2. So this is the answer for this our question, which is solve for x in the following base 2 equation, leaving your answer in base 2. And I've done that. I've converted it back to base 2, and this is our answer. So that's all for today. Thanks for watching.